Good afternoon and welcome to a special episode of The Angry Astronaut. We're going to be starting a series of episodes in a topic, or rather concerning a topic, called UFO propulsion. There are many theories about whether or not aliens are here, lots of opinions, lots of claims being made back and forth, but the one big claim that is not usually discussed in a great amount of detail is, how could they get here? If they are indeed here, if aliens are indeed paying us a visit from star systems a few light years away, dozens of light years away, or perhaps even hundreds or thousands of light years away, how are they getting here? Because after all, we are talking about civilizations that may be many thousands of years or millions of years ahead of ours in terms of their technical development. If that is indeed the case, what sort of methods might they use to traverse the stars? Now, many people talk about the possibility of faster than light travel, warp drives, that sort of thing. But if we stay within the confines of what we know to be true right now, and that is light speed is a bit of a barrier. We can't really transcend it, at least not according to Einstein. You can go up to 99.9% of the speed of light, and that is just fine, but you can't go any faster. And once again, barring things like warp drives, ways of folding space, wormholes, that sort of thing, there's no way of getting around it. And in many ways, I tend to subscribe to this notion, because if faster than light travel was a possibility, if we can indeed transcend the light barrier with means that we can understand and postulate and theorize about right now, well then certainly many very advanced civilizations would have figured all of this out by now, and we should be up to our armpits in alien visitors, which we aren't. So maybe one of the reasons that we aren't being visited every single day by a wide variety of alien visitors is because the speed of light is indeed some kind of barrier. And if it is, how do you transcend massive interstellar distances in something that resembles a reasonable amount of time? Well, there is one particular method that involves technology that we can understand, but nevertheless an infrastructure and a solar system construct that would require many thousands of years and lots of advanced engineering to accomplish. But still, we can at least envision this method of transport that would allow another civilization to send a ship that weighs as much as 1,000,000 tons, up to 50% of the speed of light, which would allow them to transcend the distance between at least nearby stars in a fairly reasonable amount of time. And believe it or not, there are indications that we have observed throughout the universe that suggest that someone may indeed be using this method of propulsion to fly between the stars, and it may be a very common thing. Good afternoon, and once again, welcome to The Angry Astronaut. Before we get going today, just want to thank everybody who's been pre-ordering a copy of my book, How Starship Will Save the World. Once again, if you would like to do that and to support my upcoming tour, all the details are in the description. I now have a confirmed date for my first location, and that's going to be Orlando, Florida. Again, all of this is in the description. And then after that, I have raised enough funds in order to cover Norfolk, Virginia, and then Pittsburgh, and after that, Toronto. So if you are in any of these cities and you're interested in attending my lecture, Please, all of the details once again in the description. Thanks very much for your support. And if you're not able to support me, I totally understand. It's certainly not your responsibility to take care of my expenses. Just please like and subscribe and share this video as much as possible. The more people who watch it, the easier it's going to be for me to fund this cross-country trip. Enough self-promotion. Let's get on to the topic at hand. For years now, astronomers have been grappling with a very strange phenomenon known as fast radio bursts, and until 2020, these phenomena were coming from galaxies many millions of light years away from our galaxy, in some case billions of light years. That is, until we discovered a fast radio burst coming from within our own galaxy that appeared to originate from something called a magnetar. A magnetar is a particularly dense and powerful neutron star that generates an unbelievably powerful magnetic field. We're talking a magnetic field 1 trillion times as powerful as our own magnetic field here on Earth. A magnetic field so powerful that it can rip atoms apart at a distance of 1,000 kilometers and was capable of compressing the magnetic field of Earth from a distance of 50,000 light years in 2004. These are amazing objects indeed, and now we believe we may have identified the culprit for at least some fast radio bursts. And for those of you wondering what fast radio bursts are, well, they are exactly what they sound like. A very quick, and we're talking a few milliseconds, burst of extremely powerful radio energy. So powerful that we can detect it from billions of light years away. Some of them are 10 billion times as powerful as the radio signal generated by a typical pulsar. So powerful that if a fast radio burst were to occur in the Milky Way, we could detect it with a cell phone. But fortunately, this particular radio burst was indeed coming from a magnetar, and it happened at a particular moment during the magnetar's electromagnetic activity. That is to say that it wasn't generating these signals constantly, but rather generated a millisecond burst of radio energy while it was pouring out enormous amounts of magnetic power at the same time. Once again, we're not even sure why it did this at this particular moment, but observations of the magnetar in question suggest that it glitched at the moment that the radio emission was detected. And by glitched, it means that it may have impacted with something, and it has been theorized that it pulled in some sort of large asteroid at that particular moment, and that's what caused the sudden burst of radio emissions when it ripped the asteroid down into its component atoms. However, if that is indeed the case, it makes fast radio bursts even more mysterious because some of them repeat very predictably. And how the hell is that supposed to happen if it's just pulling in asteroids at random? And it gets more mysterious than that, because some fast radio bursts have been found in regions of the universe that have absolutely no magnetars. For example, one fast radio burst was tracked down to a globular cluster orbiting the galaxy M81, a galaxy that is extremely close to ours compared to the other fast radio bursts that we have detected throughout the universe. And a globular cluster like this contains nothing but old aging stars, whereas magnetars are created from the sudden collapse of very large and very young stars. As a matter of fact, magnetars calm down after a very short amount of time and cease producing enormous amounts of magnetic energy and radio bursts for that matter after only a few decades. Therefore, this particular globular cluster should have no magnetars whatsoever and therefore no fast radio bursts. And yet, there it is. And this is not the only example of fast radio bursts that have been found throughout the universe that have nothing to do with magnetars. It has generally been determined that magnetars cannot be the source of all fast radio bursts, especially the ones that seem to repeat on a very regular and predictable pattern. but there's a big problem with trying to attach fast radio bursts to extraterrestrial intelligences because they broadcast on a broadband signal. That's the sort of thing that really consumes a hell of a lot of energy and would serve very little purpose if you wanted to use it for some sort of transmission. But Dr. Avi Loeb made an interesting observation about one particular repeating fast radio burst. It repeats every 157 days. Now that is an interesting number of days because what if it's not actually generating a brief burst of radio energy, but rather a constant beam of radio energy that only sweeps by us every 157 days, and we see it for only a millisecond as it sweeps by, very much the same way as we see the beam of a lighthouse for only a brief moment, at least when it's at its brightest. If that is indeed the case, and it were orbiting a star, 157 days corresponds to a planet with an orbital radius that is halfway between Venus and Mercury. However, even more interestingly, if the fast radio burst source were to be emitting a pair of beams in opposite directions, 157 days would correspond to half of the orbital period, in which case the orbital radius would be similar to that of the Earth around the sun. Now, once again, this is not extraordinary proof or anything, but when we run across these kinds of coincidences in the universe, it gets a little spooky. But what purpose would these extremely powerful broadband radio beams actually serve? Certainly not to signal anybody, because you'd never get a reply from galaxies billions of light years away. No, it would serve another type of purpose, and that is to drive something called a radio sail. A sail pushed not by light energy, but by radio energy. And the particular frequency that many fast radio bursts happen to transmit on is actually well attuned and very efficient for pushing radio sails. It corresponds actually to some of the most efficient frequencies that you could use to get the best kinds of performance. Once again, interesting coincidences. So Dr. Loeb and his associate, Dr. Siraj, released a paper in 2017, linked in the description, where they explored that if fast radio bursts were being used to push radio sails, how much of a payload could they handle and how fast would they go? And the results were quite amazing. We're talking 1 million tons worth of radio sail plus 1 million tons worth of payload to 50% of the speed of light. That being the case, then, if an alien civilization at Alpha Centauri were to have a system like this, they could drive a massive mothership weighing 1 million tons to our solar system in a mere 8 years. And by the way, this particular illustration is some conceptual art from a movie called Alien Covenant, and in that movie they use light sails, not radio sails, but the principle is very much the same. But how do you generate enough energy in order to create radio beams this powerful? Well, that's where the coincidences get a little strange as well. Doctors Loeb and Siraj also calculated that if you wanted to build a solar power station that was capable of absorbing enough light energy to generate this kind of power, it would need to be roughly double the size of the Earth. So not ridiculously huge. We're not talking about a Dyson sphere or anything like that. Only a water-cooled structure about twice the size of our planet. And interestingly enough, in a solar system known as HD 139139, we have detected several such objects that don't appear to be planets because their orbital periods do not remain constant. Whatever these things are, they seem to be moving within their own solar system, one of the strangest solar systems that we have ever found, and one that completely defies all natural explanation, at least up to this point. What if we detect a fast radio burst coming from this particular system sometime in the future? That would be very strange and a little bit alarming, because this could be used not only to propel large million-ton alien motherships to our planet, they could also be used to destroy us. Dr. Loeb's calculations were for a powerful radio beam pushing a very large ship at 1g acceleration to about 50% of the speed of light. But what if it pushed a much smaller object up to a very high percentage of the speed of light and sent it on an intercept course? Even something weighing less than a ton, traveling at 90% of the speed of light, would utterly destroy the entire surface of our planet. Of course, what sort of motivations might an extraterrestrial civilization have for destroying us? Probably very few. It would be an extremely wasteful thing to do, unless, of course, they regarded us as some kind of future threat. But getting back to less sinister motivations, this does seem to be an effective way of driving enormous amounts of mass to speeds that will allow alien civilizations to cross the distances between interstellar destinations in a reasonable amount of time. For example, Tau Ceti, which is a G-class star in our own neighborhood, lies roughly 11.9 light years away, which means that an alien mothership driven by this type of propulsion could theoretically arrive here in approximately 24 or 25 years, well within the lifespan of an extremely advanced civilization. And most importantly, the ship doesn't have to carry some sort of gigantic antimatter reactor or a tremendous amount of fuel in order to reach these kinds of velocities. The energy is being transmitted from the system of origin. But how do you slow down, I hear many of you asking? Well, there's a way to do that as well, even if you don't have a transmitter at the destination star. Instead, what you use is a sort of electromagnetic parachute. That is to say, generate an electromagnetic field powerful enough to catch the incoming ionized particles from the star that you're heading towards. Over time, this would allow you to decelerate at a speed corresponding to the velocity of the incoming particles and the number of particles striking your electromagnetic field. Yes, it would take years to slow down, but you would have years to do it, so really the entire system would still work out, although it might be a little bit difficult to leave your destination system unless you had a plan to build a new radio transmitter at this system over the long run. Who knows if that's what our visitors might have in mind for our solar system sometime in the future. And as I've mentioned a number of times in the past, manipulating the electromagnetic field of our own planet and our star would be an excellent way to travel about the solar system as well, so it would serve other purposes besides just an electromagnetic parachute. But here's the big question. Is this something that is commonly used? Because if we're detecting artificial fast radio bursts all over the universe, does this mean that this is the most efficient way to get from star to star? Perhaps so, because we are detecting these things not only in other galaxies, but also in our own galaxy. And although some seem to be generated by magnetars, by natural causes that is, there do seem to be others that do not have any sort of natural radio source, at least none that we can understand. And if at least some of them have an artificial source, we can start to calculate how many advanced civilizations might exist in the galaxy who would be making use of this type of technology based on the number of unexplained FRBs that we've detected. And the resulting numbers are pretty amazing. Dr. Loeb and Dr. Siraj predictably also crunched those numbers and came up with an amazing statistic. We're talking at least 10,000 advanced, sophisticated extraterrestrial civilizations in our galaxy capable of building things like this. Thousands of civilizations who have harnessed at least double the amount of energy that strikes their planet every single day. Those are huge numbers, and it suggests that we may very well not be alone in the universe, but there may be a galaxy teeming with advanced civilizations surrounding us, and that might very well explain why we are seeing what we are seeing right now and why UFOs have been in the news so much lately. If you would like to see the next chapter of this series, where I talk about how these civilizations might navigate the galaxy based on astronomical observations that we have seen already, phenomena that have defied natural explanation, but things that have a very good artificial explanation, well, all you have to do is hit that like. If we get 4,000 likes on this video, I will make the next chapter in this series. So until then, smash that like, hit that subscribe, please check the description for various ways to support this content, and as always, stay angry about space.